Next up, I'm thrilled to be welcoming our next speaker, Dr. Abdulwahid Mohammadian, a hydraulic engineer at AtkinsRéalis in Canada. Dr. Mohammadian will be presenting on Global Mapper's versatile raster analysis tools and application on tailings dam break analysis. Welcome to GeoTalks, Dr. Mohammadian.
Hello.
Good morning. How are you?
Okay. Hello, everyone. Can you hear me clearly? Yes.
We can hear you and we can see your presentation. It's not in presentation mode yet, but.
Okay. So let me just share my screen. Can see you screen. So you can see my screen.
Yes, we can. It's
okay.
It's in the example custom formula page.
Okay. So now it's okay. Good. So now it's in the presenting mode. Yes.
Yes. Yes. Excellent. Thank you.
Okay.
Take
great.
it away.
Let me just. I need to. Sorry. Let me.
Can you scroll down to the next one, or is it frozen? Okay.
So sorry. Excuse me. Okay. So thank you everyone. My name is Abdulwahid Mohammadian. I'm a hydrotechnical specialist at AtkinsRéalis. Today I'm going to talk about Global Mapper's versatile raster analysis tool with an application on tailings dam breach analysis. So as a background, sorry again, you see my full screen, yes? Because I see some panels in my screen, but you see my full screen, yes?
Yes, we see.
Okay, sorry.
No worries.
So as a background, today I'm going to present tailings dam breach analysis. I'll give you some background about the tailings dams and the methodology that we use by Global Mapper to do the analysis, and give some conclusion on this aspect. So as a background, and mining is with a wealth of US $14 trillion is an important industry with its significance and challenges that should be considered. Typically, tailing storage facilities are built at the vicinity of the mines, and the purpose is for the deposition of mine waste. Globally, in the world, there are more than 1,700 tailings storage facilities. Like this, for example, this is for Montpellier, and you can see the bridge before and after the situation of the tailings storage facility before and after the bridge. There are 1,700 storage facilities. 700 of them are still active. Typically, mines are closed after a while, so we call it active and closed ones. But when we consider the failure incidents, there are more than 350 failure incidents with their own human, financial, and environmental losses. I should note that the failure of the dam breach should be valid for active and passive sites, so the problem should be considered. Here you can see an example of a Brumadinho dam disaster, tailing dam disaster, which happened in 2019 in Brazil. As you can see, the massive wave of mine wastes are flowed downstream in order of seconds, and so that, as you can see, for example, in this figure, no one can react quickly, and they are buried, including the buildings and the humans and the structures. Based on the statistics, there are 260 deaths and still 11 missing. After this issue, a notice was there were notice for a better estimation of the impacts of tailings dams in the case of bridge for preparedness of emergency response plans. Here is another example for the case of Jagersfontein dam collapse, which was happened in 2022 in South Africa. Again, you can see the two images before and after of the bridge. You can see that the bridge flow impacted both communities at the left and right side. Based on the statistics, again, there were 3 deaths, 160 homes lost, with about 1,000 of people displaced and many injured. So these are just some examples to show what's the consequence of a tailings dam in the case of a failure. So what's the message? The message is that tailings dam break analysis is important and required. And because it's a geospatial issue and the communities, people, buildings, and the structures are impacted, so the GIS-based tailings dam breach analysis is important, specifically for a better estimation of population at risk, financial loss, and environmental impacts of in the dam breach. However, the problem is that the issue is that the problem is complex. We face with an issue of a combination of water as a supernatant ponds, rheology of tailings or muds with their own characteristics, and embankment dams with their own geotechnical characteristics, and also the interaction of mud, soil, and water. So this becomes a there is not yet a verified approach for simulation or analysis of tailings dam in the case of failure. There are several methodologies proposed in the literature, but mostly they are valid for if there is huge amount of data available and valid for specific cases. So based on the available current or best practice that is, for example, in Canada, proposed by Canadian Dam Association, is to use a geometric assessment, regardless of the hydrodynamic, for example. So here I'm going to show you just the overall picture of steps that should be done during tailings dam breach analysis, and then we will see, I should say that how using the global mapper we can classify these steps and do them. First step is site specifics and dam characteristics. In this step, for example, depending on the geometry of the tailings dam, several pre-assessments should be done for volume, for geometry, pre-processing of the data, and characteristics of the soil, dam, and so on. Next is calculation of tailings and water volume. And depending on the characteristics of the tailings dam, even the volume of the tailings. And having these volumes, next step is to calculate breach parameters and also rheological parameters of tailings dam. And in step 4, having considering the current condition of the dam. Next is to calculate the breach volume of the tailings and free water that could be released in the case of a failure. And step 5 is breach volume calculation of the stage storage relationship or stage volume curve from the breach volume. And in step 6, by having this stage volume curve, next is to calculate the breach outflow hydrograph or kind of hydrodynamic computation. Step 7 is hydrodynamic modeling and preparation of inundation maps. And in step 8, analysis, consequence analysis, and hazard calculations. So these are the overall picture, but when we consider from the global mapper perspective, a process can be classified in 3 steps: pre-processing of all the data, hydrodynamic modeling or flood mapping, and post-processing of the results of the flood mapping. Global mapper is a key help in pre and post-processing of the results, and only for inundation mapping, we need to go for hydrodynamic modeling. For example, for the case of pre-processing, using global mapper, we can, all the prerequisites, raster and vector analysis can be done. And we have come up with the calculation. We come up with the calculation of breach volume and stage volume curve, and so on. Then we feed the hydrodynamic model based on the stage volume curve and do the inundation mapping. And during the flood mapping modeling, the rasters of depth and velocity are prepared and exported to as a rasters. So again, we come back to global mapper for by having the raster of depth, velocity, water surface elevation, and so on, for calculation of flood severity, hazard, and population at risk, potential loss of life, and many more. As a first step, we want to know how we can use the volume calculations. Depending on the geometry, as you can see, there are 3 different geometry for tailings dam. So central, upstream raise, and downstream raise. Depending on that condition, we have a geometry also for tailings. This can be tailings and also the situation of supernatant pond. So, for example, for this case, we have we should calculate the volume of supernatant pond, because we typically assume that in the case of breach, total volume of water is released. And then we should calculate the breach volume part from the tailings and also breach volume from the dam. So next step, in this step, the first aspect is calculation of supernatant pond. As you know better than me, the digital elevation models or lidars typically doesn't go below the water surface. Any topographic feature can be surveyed by the lidar or digital elevation models, but for the lakes and waters, they don't reflect below that. So, but for the lake or supernatant pond, typically the bathymetry is surveyed using, for example, sonar and so on. So when we have the contours of the bathymetry of the lake, then these are in the forms of X, Y, Z data. So when we have them, we can, using the operation of analysis and then grid, we can create elevation grid using 3D data. So we have the raster of this topography, this bathymetry, and then we can superimpose it on the excuse me. We can calculate the elevation grid and superimpose it on the digital elevation model and export both the digital elevation model and grid as a new digital elevation model. So here is the picture of the, as I mentioned, this is the typical LiDAR or typical digital elevation model. As you can see, for this case, the LiDAR cannot go below the water surface. And at the right side, this is the processed digital elevation model using global mapper. So we created the grids of these contours and then superimposed and exported as a new layer. So now we have the volume of now we have the current condition of a tailings structure. Next is the calculation of breach volume. Depending on the geometry of the dam, breach volume is partly from the dam and partly from the tailings site. Here is another case. You see that, for example, for this dam, this is the inundation maps in downstream. So the question now is how to calculate when having the topography of a site and bathymetry included, how to calculate the breach volume. So for the case of the large dam, that could be a lot of volume from the dam, and also the volume from the tailing should be calculated. As I mentioned, Canadian Dam Association has a guideline for calculation of breach volume, and its geometric method, which is also named cone of depression. In this case, based on the location of the dam, there is with a specific radius which is determined from the rheological characteristics of the tailings. We have the angle of repose, and it is reflected inside the tailings dam, and based on that, a cone is dredged with a center at the location of the breach. For example, here you can see the cross section for a schematic bridge at the left side. So partly from the supernatant pond and dam, and also the mobilized tailings is determined. In Global Mapper, to do this analysis in Global Mapper, firstly we need to create an area feature, which is area feature with this characteristics. So the procedure is a creation of an area feature with a center at dam crest and the radius of interest based on the details of the bridge is created. And then, because this area feature has no elevation, we have to modify the elevation. Firstly, assign the elevation of the tailings, and then change the elevation. For example, at the location of bridge, we assign the elevation of the ground, and at the location of the tailings, we assign the elevation of the tailings. And then using the advanced feature creation option, and then calculate the flattened site grade, we apply that dredging. It's kind of a dredging because now the area feature has elevation and it's dredged to the surface. Here is the picture of the result. For example, for a specific dam at the left side, we have seen that for example, we consider that the critical location for bridge is at this corner, then an area feature is created with a shape of that cone. At the location of the hypothetical bridge, the elevation of the ground is assigned to the area feature. At the location of the tailings dam, or at the radius of that, the boundary of that radius, the elevation of tailing, and we apply that flattened side, calculate flattened side, then this shape is calculated. Next step is the calculation of the breach volume. Again, because of the complexity, there is no methodology for for real breach procedure, I mean real breach progression. So there is a parametric approach in the literature. For example, for breach we have it is recommended that, for example, 1 to 5, the suggested range is 1 to 5 times of the height of the dam, and for the side slope is 1 to 1, or vertical to 1 to 1 ratio. So 1 to 0 to 1 to 1 ratio, and typically the breach bottom elevation is considered at the ground level. So we have this information from the guidelines. The question is how to implement this these conditions in global mapper. So again, the situation is like with a minor modification. The situation is like the creation of the breach. Calculation of the tailings breach. Again, we create an area feature, as you can see here in the red. We again, the area has no elevation so far, so we assign the elevation of ground to the vertices. But now, before flattening the site, we need to apply these conditions, these parameters. For example, for the case of 1 to 1 ratio, we should allow cut a slope around the edge of 1 to 1 ratio, and flatten to area height, because now the area feature has height. The field slope is not the case for this condition, because we are cutting the dam. So again, after having this, you can see the post-failure. In this image, you can see the post-failure condition. And one of the good feature of Global Mapper is that we can see them at the same time. Because of the docking feature of the Global Mapper, we can see them at 1D, 2D, and 3D views at the same time with an interactive mode. For example, any cross-section that you draw here as a path profile, it is shown here in 3D, and the volume, and it is also shown in one-dimensional. So for example, for the case of our study, this line is this black line is the initial condition, pre-failure condition, or initial tailing level, and after application of that breach from the tailings, and again, and next the tailing breach from the dam, you can see this final setting level, final tailings level. And you can see that we have applied based on that geometric. Here, just the question is that what is this slope? This slope is coming from the rheological analysis of the site. So after that, for example, 1 degree, 4 degree, or 3 degree can be calculated and applied. One of the interesting features in Global Mapper is that you can see a real more accurate, the realistic situation of the site. If you superimpose the satellite imagery on the LiDAR, it can apply it on the satellite imagery, so it gives you a better understanding about what happens as a post-failure. So, for example, when this is applied and then we load satellite imagery, you can see that this applied to the location and have some insight about what is expected in a post-failure condition. Next is to calculate the calculation of the volume. So now we applied that. We applied all the breach from the tailings from the dam, and we applied them. Now the question is how to calculate this stage volume curve. So there are different methodologies, but the methodology that, for example, I apply is that create an arbitrary area feature and calculate the volume using this icon or using analysis measurements and volume measure calculation based on the default setting, or you can change the setting. But here we should perform multiple calculations over a range of base height and define the step size. For example, for the case of 860 to 900, I set that 40 meter by 1 meter interval I calculated. But the point is that if the area feature is arbitrary, then you have to apply them in both conditions, before and after failure, and then subtract the two curves to have the results of the curve. The second methodology is to just create the area feature just at the location of the breach. And in that case, if you calculate the volume, the stage volume curve is exactly for the case of the breach. So here, for example, this is when we calculate the results, then we can copy and paste in Excel and just to select the cut volume, and this is the result of the stage volume curve that is determined by global mapper. Post-processing, actually, I should say that yes, having the until this step, this is pre-processing, then we got the stage volume curve and go to the hydrodynamic modeling and do the inundation and hydrodynamic modeling, and as a result we have the rasters of flood severity, flood depth, flood velocity, and flood elevations. For example, here the results of the modeling can be loaded here, and then using global mapper we can post-process it by calculation of flood severity and flood hazard. So for flood hazard, actually, there are typical methodologies in the literature. For example, some of them is just a simple multiplication of depth and velocity and define a range. In this case, it is very easy to global mapper. We just need to do using the built-in combination tools in terrain modification, in combined terrain option that is available in global mapper, and just define the ranges. But for this case, we have to use raster analysis tool and apply different formulas. For example, here you can see analysis and raster analysis tool. So for calculation of flood severity, raster calculator apply formula, and then it asks for input rasters that are here, depth and velocity, and apply built-in formulas. For example, just if for the case of just multiplication, typical math operation are available to select, or we can define for the case, for example, for this case, we can for example, for this case, we can define this formula in the raster analysis tool. And the results in this case, after this procedure, the results are exported as a new raster. Here is an example of the results. For example, because it was I applied this formula into raster analysis tool, you can see that it's a very simple line, and the formula is like writing the formula in Microsoft Excel, just a condition to define the range, and then we have seen for the custom formula we have seen the hazard, and then by defining a legend, we can see that, for example, what is the high danger zone, medium danger zone, or low danger zone. So as a conclusion, tailings dam breach analysis is a complete GIS-based problem. Global Mapper is a versatile GIS tool for tailings dam breach analysis. Pre and post-processing tasks of a tailings dam breach are fully doable. Many built-in operation for raster analysis are available in the tool, and there are flexible features for raster modifications. And the tool is user-friendly, quick, and a simple GIS software. Thank you very much for your attention.
Dr. Mohammadian, thank you so much for joining us today and for sharing all your knowledge with us. I'm actually originally from Brazil, from a city very close to Brumadinho, where that disaster happened in 2019. So I've learned a great deal from you today. I appreciate your time today. We do have a few questions for you.
Sure.
Let me just take a look at our little questions here. So the first question I have here is, how did you collect or find your terrain data?
Actually, Global Mapper, in the Global Mapper, when we load a layer, there are online available tools so that we can access to for example, there are many global resources for free built in Global Mapper. So you don't need to think about any other sources. So Global Mapper can feed you. For example, at the location that we load a layer, it is possible to load terrain data from the global satellites.
Excellent, thank you. And the next question is, how many dams have you been able to measure that way with this process that you showed us today?
How many dams? Okay, it depends. Actually, the calculation, the number of dam is a procedure that is done during a dam safety review. So, for example, using this is the automatic setting. Sorry.
No, that's fine.
Actually, for example, based on the dam safety review, the critical dams are selected, and we should undergo the tailings dam for the critical dams.
Excellent. Well, that's all for today. If any other questions come through throughout the day, we'll email them to you, and we'll give you some time to answer, and then we'll get back to the attendees. But thank you so much for joining us from Canada today and for sharing all this amazing knowledge. I must say that Dr. Mohammadian was one of the winners of the Global Mapper Master program last year. We were really impressed by his work, and we are so glad that you are able to join us today. Thank you so much, sir.
Welcome.
You have a wonderful day.
You too. Bye-bye.
Bye-bye.